Okay, we're in section 30 of the notes. It's the section on Sage now. So we're going to look at Sage code. Hopefully this is kind of well understood at this point. What may not be well understood at this point is how extensive the Sage program is. So let me just go through this stuff over here. Reset. I'm just typing the code that I'm seeing in my notes. Excuse me. I'm defining two variables, X and Y. Again, reset basically purges anything that's from prior problems that I don't want. And then, copy paste now. Let me do that. I'll copy this one over here. Now, certainly when I copy it, I'll read it to you. I'll tell you what it says. Whoops, I didn't mean to do that. Get my mouse over here. Okay, this is, I'm assigning to EQ1. EQ1 is shorthand for me for equation one. And equation one is 9x squared minus 4y squared minus 18x minus 16y equals 43. All right. Now, certainly I'm going to, do this implicit plot now, see what I get. And that's going to open up that. And it's a hyperbola. All right. Now, where did you study hyperbolas? In math 120. All right. But what kind of, you did conic sections, you did circles, parabolas, ellipses and circles, and you also did rotations in math 120 because these rotations have to do with trigonometry because you're rotating through an angle theta. All right. Let me do the next one. Just doing a copy paste. Again, my intent here is to read it to you. Now, if we look at equation two, what do I have? Equation two is 7x squared minus 6 square root 3 x times y plus 13y squared minus 16 equals 0. And yet you may recall back in math 120, this is substantially a more difficult problem because we have a term in it, xy. And what we did there was we went through this process to eliminate that term by rewriting the system x prime, y prime. And that stuff was done in math 120. And optionally, it was reviewed here in math 122. And again, if you really need to see a detailed presentation of that, you would go back to the math 120 notes and look at that. But anyway, what I'm going to do is I'll do this over here. I'll type that in and it plots it out. Now, what is it? It's a rotated ellipse. All right. So what I want to do is I want to go back to the notes and I want to see if I can do this example over here. All right. So what I'm going to do is, I'll just put this up here and I'm going to, type those equations in now. So I'm going to call the first equation EQ1. So I'm redefining EQ1 as x squared minus 4 star y squared. And again, I'm trying to learn from my code and possibly from my past as well. Maybe I want to do something different. All right. And then minus 64 star y minus 247. Double equal signs indicating I have an equation. Let me just read it to you. Let's see if I got that right. X squared minus 4y squared minus 10x minus 64y minus 247. Looks good. All right, no error message. That's great. And I'm going to define equation 2. And that's going to be, what's that going to be? 16 star squared. All right, plus, whoops, I didn't do x squared, did I? By the way, double star is a square. All right, I like the caret better though. Plus 4y squared. Yes, I need to put the star in there. Minus 160x. Let's see, plus 64y. That's star y, right? And then plus 400 is going to be assigned 0. And that's going to be equation 2. All right, I'm going to do something a little bit different now. I'm certainly going to do a implicit plot, but what I want to do is I want to assign it to an image, and so I'm going to create a variable img. Let's see 1, and I'm going to assign that implicit plot. I'm going to hit the tab button, and when I hit the tab button, I'm going to see a bunch of choices there, an implicit plot. And what I'm going to plot is I'm going to plot equation 1, EQ1, EQ1. And now I want to look at my graph. I want to see if I can reproduce this. All right. And I can put the X's down first. And, it's really going to play around with it. X going from, I don't know, minus 16, let's say, up to, I'm going to say about 24. Remember, if I make a mistake, it's going to come back and tell me I made a mistake. And then Y is, well, I got to look at it. And how low does Y go? About, say, minus 22. And how high does it go? Again, I'm looking at my graph. I'm going to say about 4. All right. Now, this is now image 1. Image 1, now it's being stored in memory. I'm going to do image 2. Excuse me. Implicit plot again. Again, remember, if I hit tab, I'll see the command. Whoops, I didn't want 3D, sorry. I'm going to do equation 2 now. Q2. And, just play it safe. I'm going to copy paste. I'll copy this up here. And I'll paste it in. Now, I can use a command called show, like img1.show. Let's see what that looks like. Well, I got that. I was kind of expecting that. And let me go back to my command. And I'm going to take both of those things and combine them together. So I'm going to take image 1, and I want to combine it with image 2. Add them together. Let's see what happens. Dot show. Well, I'm getting it. Now, someone's going to say, which graph is better? That's up to you. But I'm seeing it, and I got a relative idea that what I'm looking at, it's missing the X and Y axis, by the way, but that's not important to me. X axis would be right here. That's 0. You know what? I think I might have made a mistake in this. Let me take a look at that. Because I noticed if X is 0, it looks like at least, whoops, let me just do something here. No, it's an optical illusion. All right. I'm seeing the same graph over there. It's an optical. When I first looked at it, I thought that this thing over here was above the x-axis when it wasn't in my picture. All right. And the y-axis is over here. I'm just lining it up. And that looks about roughly right. So I'm going to say it looks like a good picture. All right. Now, what's the point of this over here is to visualize. And that's, if you go back over the homework, you'll see that. Now, again, if you go back over the notes, you're going to see other examples that you may decide yourself, you know what, I need to practice my SAGE, because when I move forward to like NJIT or any other four-year institution, that I need to get better with using a computer algebra system. And go to town. Look at these graphs over here, provide them to you. Their learning process, you would type that in, implicit plot, you would see if you got this picture over here. So forth and so on. There's plenty of examples in the notes, and I certainly give you pictures that you might find a little bit better. Again, that's up to you. I do want to point out that SAGE is a little tough to use. And I always say it's nice to have options. I just want to go to one other option with you. And I want to go to using this application called Grapher. All right. So let me just go through Grapher. And I'm going to type this in. It's actually easier for me to do that. And 13x squared. All right. Plus 6. I'm just simply reading what's in the notes. 6. Let's see, square root. So times the square root of 3, and then xy, right? And then plus 7y squared minus 80. Whoops, made a mistake there. Minus 80 equals 0. Now, granted, I have a picture, and I'm hoping when I do a picture, that's relatively the same picture. All right, let me just zoom out a little bit. I'm going to get rid of the grid because I just don't like the grid. All right, accent grid. And let me get rid of that. I'll get rid of the frame and I'll get rid of the grid. I do this often enough that I probably should just make that the default. Now, what I want to do is I want to just go back over this and talk about, looking at it. What number is this over here? So this is number 19, right? So sketch the graph of, oh, that's not the one I want. That's a degenerate. This is going to be 145, figure 145. Let's go back over here. So I got this one over here. And someone says, there's other things in it, and there's work over here for you. It's a rotated problem. All right. And this is the same exact problem I give my Math 120 students. It's the same problem. Actually, I just copy pasted it. So what I want to do is I want to draw the asymptotes in. I'm sorry, not asymptotes, the rotation. And the rotation's pi over 6. all right? So someone says, if it's pi over 6, everything's being rotated pi over 6. All right, now someone says, what's pi over 6? Well, if you thought about it, pi over 6 times 180 over pi would be 30 degrees. So the rotation is 30 degrees. So what I want to do is I'm going to graph a line that has a slope of 30 degrees. All right, so that's going to be y equals, and let's do that. And I'm rotating the x-axis now. So I'm rotating at 30 degrees. What would that be? 30 degrees would be, let's see, the slope would be, let's see, 1 over root 3. So I'm going to say x divided by root 3. And I'm seeing that. All right, that's the x-axis of 30 degrees. Now the y-axis is also being rotated 30 degrees. All right, so I'm going to put a new equation over there. Then the question becomes is, what's the slope of that guy going to be? Right now, this is, for a lot of students, really difficult. But again, you're visualizing it. And I hope you realize it's perpendicular to that line y equals x over root 3. So what I'm going to get over here, well, it's a negative slope minus, this is what you learn math 100, square root 3 times x. Let's put that down now. I'm getting that. I'm going to change these guys over here to dashed. Give me a moment to do so. And let's look at our picture and see how we did. All right. And again, the picture's given over here. This is the one we try to imitate. And this is what we're looking forward for you to do, is to be able to reproduce. All right. That's part of your learning curve, to be able to reproduce what we present to you. All right. That's a whole point of learning, to reproduce that knowledge. Of course, that's the simplest thing you do. Then there's the next step, is synthesizing it into something bigger than what we're presenting to you. And that's part of your learning process, to synthesize this into bigger and bigger and bigger problems. Hopefully it'll lead to a career that you find exciting and rewarding. Thank you.